Okay, let's have a look at this one. The parabola y equals x squared meets the line y equals x at 0. Well, that's the origin, isn't it? 0, 0. And the point A, 1, 1. And the volume of the solid generated when the region between the curve and the line, find the volume when the region between the curve and the line is rotated about the x-axis. It is actually the example that I talked about in the previous video. Let me draw it up again for you. Well, I'll draw it this time, whereas it had a proper diagram drawn for you before. So we've got y equals x squared, we've got y equals x, straight line. They intersect here and they intersect here at 1, 1, and that's the point A. So we have a region, and this is my region. This is the unusual thing that's going to be rotated now around the x-axis. So rotating it, we'd have similar concept down here, similar concept, and this thing is going to get rotated around the x-axis. So to find its volume, first off we want pi times the integral, and we're going around the x-axis and it intersects over at 1, so it's from 0 to 1. Sorry. So we've got volume is pi times the integral 0 to 1 of the straight line, because we've got to establish the region to start with. So the region is going to be made up of the straight line, which is straight line, and because it's volume it's squared minus the parabola squared. So the straight line squared, the straight line was just y equals x, so it's x squared, because remember that was y1 squared minus y2 squared. And y1 is our straight line, and y2 is our parabola, because it's underneath, and square that, you get x to the 4th. So our volume is pi times, possible to integrate this, add 1 to the index, divide by the new index, add 1 to the index, divide by the new index, and we're going from 0 to 1. So the volume is pi times 1/3 minus 1/5, subtract 0 minus 0, not going to have any impact. So the volume is 1/3 minus 1/5. In terms of 15ths, we've got 5 minus 3, which is 2/15. So it's 2 pi on 15 units cubed. 2 pi on 15 units cubed. This next example has two complications. Well, one is a complication and one is just like a little twist. It's talking about an example where we've got a region between two curves from y equals a to y equals b around the y-axis. Sure, yeah, we're familiar with going around the y-axis to create a solid. And we would know that the volume around the y-axis is still this pi times a to b, the boundaries, of whatever the top function, which is the one to the right, minus the one underneath it, and both of those are squared, and subtract the top one minus the bottom one. And of course we've got our formula in terms of y's. We've made x the subject, and that would give us the volume if we did that. In this example, it says find the volume of a spherical cap form when this curve is rotated about the y-axis from y equals 1 to 2. Now, from y equals 1 to 2, let's have a look at what that's going to be like. So you can see here I've drawn the circle. X squared plus y squared is equal to 4 is a circle. Radius 2. Just didn't draw the bottom of it because we want from y equals 1 to 2. So this would be 1, and this is up here at y is 2. And yeah, you could probably see if you cut that off there, yeah, you've got a solid, and it is like a very neat fitting cap. So to get the volume, we've got pi times the integral 1 to 2, and yeah, this is not one that I've made up. We've actually got the correct boundaries this time. We're not talking about part of trying to find a volume that doesn't actually exist. So yeah, this does exist from y equals 1 to 2. I guess it's not really a region in that it's not formed by the finding the area between two curves. However, it's not a very straightforward sort of function really, but it is actually made quite nice for you because remember that's basically the definition, that the volume is pi times the integral from, in this case, 1 to 2 of our function in x squared. Now it's very easy to get from x squared plus y squared is equal to 4 just to x squared, 4 minus y squared. So we want the volume pi times the integral 1 to 2 of our 4 minus y squared. So no problem taking the integral of that. So it's 4y minus y cubed on 3 from 1 to 2. Our volume is pi times. Now we've got to be a little bit more careful. 4 2's are 8 minus 2 2's are 4, 4 2's are 8 on 3 minus bracket, because we do have to do this a substitution here. I think all of the other examples that I've done, the other variable, the other number that we were substituting in was 0, which didn't actually affect our calculation, but subbing in a 1 will definitely affect our calculation. Please put in a bracket. 4 minus 1/3. Let's see how we're going. Volume is equal to pi times 8 minus 8 on 3. Now let's do that as a 24, 20, as a 3. All on 3, so we've got 24 minus 8, which is 16. And 4 minus 1/3 is 3. Where can I do that? 3 and 2/3. 3 3's are 9, 10 are 11 on 3. So we've got that the volume is pi times 16 on 3 minus 11 on 3, which is 5 on 3 units cubed. Or we could have the 5 at the front, 5 pi, all on 3 units cubed.